the basic idea of why we're doing LID and what characteristics of LID design, including site layout and the design and construction and even the maintenance of bioretention facilities and other LID features and facilities that really make the difference in how effective our efforts are. And I think that if we all have a common understanding of why we're doing it and the key elements in design and construction that help achieve what we're trying to do, will be a good way down the road toward improving LID installation, getting towards that point where, you know, maybe some years from now, as we travel around the Northbay counties and go to stores or cruise through downtowns or walk in our neighborhoods, that when we see these facilities, we go, wow, you know, there was some thoughtful design, some appropriate construction details, and we can say, yeah, this is a facility which is sustainable, resilient, robust, will be here for many years, serving the environment and serving the community. So we're aiming for really getting improving the process so that as our municipal reviewers receive applications, go through them, that we shorten that process of back and forth to get to an acceptable design and a complete application, and you know, approval of the stormwater control plan, which of course dovetails into approval of the development project as a whole. So, you know, we're aiming for efficiency and to promote the development process, not to hold it up by basically improving the flow of information, improving our common understanding of how to implement low impact development, what the requirements are. And so when those applications come in, the stormwater control plans come in, they are as close to complete as we can get. So with that, our agenda for today, we're going to cover a brief little piece on the why and how of low impact development, going a little bit deeper into what I was just talking about. And I know many people here have been using the manual. There are probably some others who haven't. And so when we have these sessions, we always have a mix of folks who have a lot of experience and folks who are just coming for the first time. So we'll have an overview of the post-construction manual, what's in it, the chapters, what each is trying to accomplish. And this is really just to familiarize you with the resources that are available for preparing stormwater control plans. And then we have a number of topics on planning, design, construction, and maintenance of facilities. We have 8 of them, and each of these connect to different parts of the manual. We'll be talking about the applicability of requirements, of the E12 requirements. We'll have a little session on small projects and doing a design for how you go about doing a design for a small project. A really key one that perhaps sort of the center of what we're trying to accomplish is coordinating the design team, is figuring out how we get professionals from different disciplines working together in order to have a fully integrated LID design on the development site. We'll have a topic on what needs to be shown on construction drawings, some of the details of bioretention construction and design. A little section on bioretention soils. Might not be the most important overall thing in the picture, but it sure comes up a lot, is how to ensure that the planting material is functional. A section on plants, mulch, and irrigation, also something that comes up frequently. And then we'll be discussing operations and maintenance. And then we'll have a little exercise at the end, just looking at taking a long look at a bioretention facility and seeing what we notice and sort of reviewing the various lessons that we've touched on over the course of the morning. Any questions in the chat at this point? Anybody got anything to bring up? A particular issue that they would like to see covered? Go ahead, put it in the chat, and we'll make sure that we get to it. So let's move on to the why and how of low impact development. So this is sort of just a brief review of the problem that low impact development is trying to address. And that can be summarized in one word, which is imperviousness. And the effect of urbanization and the accumulation of impervious area and conversion of areas that have soils or vegetation and converting those to roofs and pavement has an accumulation of negative effects on streams and other water bodies. And to summarize those, get my device here going. The start of this is at the what this table shows is at the site scale. These things happen at the watershed scale. These are the results when the sites accumulate beyond a certain level. That trigger has been put out there as 10%. I think that might be somewhere arbitrary. I think it's better to think of it as basically the less imperviousness we have, or the more we can mitigate imperviousness, the more we can reduce these watershed scale effects. But at the site scale, as I think anyone who does drainage design or works in drainage engineering is most immediately familiar with, as soon as you pave a site, the maximum flow off the site during a rainstorm, the peak, gets much higher, and particularly in smaller stream beds nearby where that discharges, it can cause flooding and scouring. That's why we have flood detention. Similarly, there's some technical engineering term, time of concentration. And when that's reduced, basically what that means is that runoff is getting to the point where it's concentrated and about to be discharged much faster in a shorter amount of time than it would in a natural landscape. And this can cause flash flows, which actually can bounce the biota right out of the pools and streams during a downpour. You get more frequent runoff. So discharge happens when runoff didn't previously occur. So I think we've all had the experience of walking in the woods in the rain, and you can see that it takes quite a lot of time and quite a lot of rainfall before you start to see puddles and you start to see water moving over the surface. But even the slightest drizzle in an urbanized environment will cause water pretty quickly to start running in the gutters, and that goes directly to creeks. And so you see runoff happening, and this increases runoff durations. So overall, taking it over a long period of time, over many years, you get flow for longer at even when it's not at a high peak. Even moderate flows can cause stream erosion. And that is the basic problem of hydromodification management, which we'll touch on a bit later. More runoff means higher pollutant loadings. That's basically the driving factor is when we try to figure out how to deal with pollutants on the sort of total amount of pounds that go into the bay or other water bodies, the more runoff you have, the higher pollutant loading. And so when you have more imperviousness, more pollutants. And then the energy of the runoff, since you have higher flows, it's more turbulent, and you get this effect is that it can convey trash and other pollutants down the storm drains and into streams. It's a major concern and area that the Water Board has been working on for some years now. When you have less infiltration because the surface of the ground is covered in impervious surfaces, that means that you reduce the effect of water seeping into the ground, traveling through the ground slowly, and then emerging in streams. And so seasonally, the amount of base flow that you have in your streams and the length of it, how long it persists into the dry season, gets reduced, and that obviously has effects on the biota in the streams. And then this last one is actually, I think, often overlooked because our regulatory system is focused on total loads of pollutants or concentrations of pollutants in the water bodies. But often the biggest effect on local streams is very transitory. It happens when a shock load of pollutants comes off of a parking lot in the form of oil and grease, trash, biological oxygen demand is flushed into the stream. Often this occurs in the Bay Area ecosystem when we get those storms in September when it's hot. The streams are flowing very low, if they're flowing at all. And the movement of highly polluted discharges into the streams at that time can be particularly devastating. And this is sort of a key thing, actually, when we think of how, are we doing any good with our low impact development? But we're definitely doing good in that area because those kind of low intensity discharges that occur either from dumping or from small storms at the end of the dry season are very effectively prevented from reaching streams by bioretention or other low impact development measures. So essentially, we can take this same idea here, what happens at the site scale and what happens at the watershed scale, and look at the way that LID reverses this for us. Is that at each of these things, each of these effects, when implemented at the site scale, LID will mitigate essentially every one of these by detaining, retaining, filtering, infiltrating runoff, and will have some incremental effect on reducing that in the catchment and the watershed as a whole. The, of course, sort of daunting or, somewhat why am I not advancing here? Excuse me. There we go. So the daunting aspect of this, in terms of actually having a beneficial effect on our streams and bay, is, well, this is just one site. We're just doing one site. We're trying to do LID on one place. And really, what is the benefit of that when you measure it against the whole bay or even a major trunk stream? Because in order to really have an effect, we would need to change a substantial proportion of the existing development. And I think, looking at this, we can imagine that we really need to end up managing somewhere down the road thousands of individual sites. And I think we can say that already if you look at the Bay Area as a whole, we do have thousands of sites with LID. And so we certainly have thousands of individual LID elements, individual features and facilities on those sites. They may need to be managed, in our social system via thousands of individual property owners. And that's a very difficult thing to do. And we need to keep them going and keep them there for a very, very long time frame. So the only way we're going to get where this can go is if we have a system where each of those facilities, once it's built, persists, for many decades. And the reason I'm focusing on this is that this is really the driver for both the site layout characteristics that we're aiming for the construction characteristics, the design, everything that's in the manual is aimed toward producing resilient, robust facilities that are integrated into their community, are valued by the people who live and work in those communities, so they have a incentive and a desire to see them maintained. And I think only by accomplishing that, only by making low impact developments a integrated part of what we build, and by making it something that people encounter every day, as they work, play, live among, using their sites, using their landscape. Only if the low impact development facilities are an integrated part of it that they encounter every day, is it possible to achieve this robust, resilient system on a watershed scale. We got a poll. This is great. I think actually these are all of these things are true. But maybe we get to decide which one we want to focus on, whether it's at any given moment, whether it's that we're trying to have this beneficial effect, that it really is just one more thing that you have to do to get something developed, and that we need to honestly recognize that when you put more requirements on a development, that it gets harder and harder to get that development built. And so then that puts the responsibility on all of us as we fulfill the regulatory requirement, jump through the regulatory hoops, that we both maximize the concomitant benefit to the environment, to the community, by doing it as well as we possibly can. And also by facilitating our review process and our, making sure that people who are doing the designs know what they need to show, and making sure that people review know what they need to review, so that we can get these things built, get that low impact development installed with it, and hopefully retain it over many decades after the project is built. Yeah. Close that. And again, any comments, questions, feel free to use the chat. So in this section, we'll review what's in the manual. And the manual that's used in the 4 Northbay counties, it is kind of a condensed version. We took what was in some of the other manuals, particularly Contra Costas, that were used in the phase 1 counties, which have more stringent and more detailed requirements. Condensed, simplified, tried to improve the way that it comes across, and developed the current manual, the post-construction manual. show it here for the 4 North Bay counties. The elements within it, the chapters, basically an introduction about the requirements, path to compliance, explaining here's how you get your project approved, detailed step-by-step instructions on preparing a stormwater control plan, instructions on documenting LID design, including the design and construction of facilities, and instructions on preparing an operation and maintenance plan. So we will get into on each of these chapters. We have corresponding topics that get a little bit more in depth with some of the detailed things that are in the chapters. In this case, in chapter 1, we have a topic which we'll be addressing after this little piece of the presentation, specifically on the applicability of which requirements apply to which types of projects. In chapter 2, this is the outline. This is the path. And we encourage applicants to participate in a pre-application meeting with municipal staff, to use the manual, prepare a complete stormwater control plan, prepare a complete stormwater facilities operation and maintenance plan, provide enough detail on their project design to resolve questions and issues about how the LID facilities are being integrated into the project design. Some things to check during construction, and basically the key items during construction need to be inspected, and the process of transferring maintenance responsibility so that facility has someone who's responsible for it over the life of the project. Chapter 3 is step-by-step instructions on preparing a stormwater control plan. And we get into a topic on this, on preparing a complete submittal. And which will focus on the key things of preparing a complete stormwater control plan exhibit. But I certainly encourage anyone who has not looked through this to use this tool, these steps, and the checklist that's in here to ensure that they get as close as possible to a complete stormwater control plan on the first go. Chapter 4, I guess what I really want to point out here is, in addition to these documentation steps, and we will be going over these in a particular topic, but these design criteria that basically go with this illustration here. This is a bioretention facility, and the notes and design requirements that go with each one of these elements are key. Going back to that, my comments on trying to ensure that these facilities are robust and resilient, that they last for decades. We will discuss how each one of these elements and the design criteria for each element is key to achieving that. And then chapter 5 covers how to prepare an operation and maintenance plan, and keeping in the style of the manual, it has a step-by-step approach to preparing it. There are a series of appendices. One is a simplified way of making sure that any particular sources of pollutants that are on the site are identified, and that the corresponding best management practice for controlling that particular source of pollutants. An example would be trash area associated with any kind of commercial facility or multifamily housing has elements that protect stormwater. There's another appendix is bioretention construction checklist. Details could be taken out to the site, adapted, used to ensure facilities are constructed properly and all those design elements have been installed correctly. There's a stormwater control plan template for small projects. We'll be discussing in more detail. A template for regulated projects, which can be obtained in Word and isn't a substitute for the manual. It actually sort of provides prompts where to fill things in, and then the manual should be referred to for actually figuring out what to put in there. There is a plant matrix, list of plants, which should be work in most bioretention facilities in our area. And then there's these additional resources. I took a screenshot here of McStop's website, but there are other things that can be downloaded online, which also help. There's an Excel-based calculator. It doesn't have to be used, but it can be a pretty useful tool. There's example stormwater control plans, one for a commercial site and one for a small residential subdivision. There are example operation and maintenance plans that go with those same example projects. There's a template for an operation and maintenance agreement. There's, if you do have a project where a lid is not required, these are very rare, but just know that if you do have such a project and an underground facility, like a vault-based media filter is installed, the manual does include or includes as this external document technical criteria for those facilities for their design. There's also an inspection checklist for doing operation and maintenance inspections. So we have another poll.
And again, just to remind folks, if people have questions, feel free to raise your hand or put the question into the chat and we'll bring it to Dan's attention. Thanks.
It's good, really gives us a sense of who we're among in our virtual meeting here. And we seem to have a good balance of folks who are relatively new to this, perhaps dealing with the manual for the first time, haven't opened it yet. So I'm glad we had the opportunity to go over it. Folks with some experience, folks with quite a bit of experience, who I hope will be among those who jump in and tell me and others what their experiences have been like, the issues that they've encountered, and of course our municipal reviewers. Rob, I'm glad we did these polls, so I know people are out there, you know.
There aren't just black squares out there. There are people listening. Thanks, Dan.
Okay, just a couple more beats, moments, and then we'll move on to our 8 topics. We're going to do 2 of the topics and then take a 10-minute break, and everybody can do what they need to do, and then we'll come back. We're running about 15 minutes ahead of time, which is fine. I hope we get some questions so we can have some back and forth. Okay. Very useful. All right, let's move on to some key topics here. These are the list I noted before. We'll talk about applicability, about small projects. This key one about coordinating the design team. I hope we can hang out on that for a while since we do seem to have the time. What needs to be shown on construction drawings, also pretty key. These are probably the two longest ones, and then we'll cover soils, plants, mulching, irrigation, and operation and maintenance. So let's talk about applicability. You know, it's not the most exciting topic really, but boy, it is one that ends up being a common topic of discussion, since what everybody wants to know is, do I really have to do this for my project? And I want to point out table 1.2, where we tried to really distill and summarize and compact the requirements that are in provision E12 into a simple table, even readable, I hope, on your screen, that says this is what you got to do. And it isn't meant to provide the complete detail, but just to give overview and a first blush, or, you know, first in or out kind of view of what needs to be done. So going over this, the requirements is if you're building one single family home that is not part of a larger plan of development, so not two homes built separately, even at different times if it's part of one project approval, but just one home. The requirement is that if it creates or replaces 2,500 square feet or more of impervious surface, it becomes this small project. Small development project, has its own special path to compliance. It's in Appendix C. Very simple to do. You know, talk about a regulatory hoop. It is something of a regulatory hoop. We will be having getting into that in more detail, and some of the changes that the Northbay agencies made to clarify their expectations on that when the manual was reissued in 2019. The small project category also applies to any other type of land development that creates between 2,500 and 5,000 square feet of impervious surface. Above that, you're into a regulated project, which requires a stormwater control plan, and requires that in addition to reducing runoff and dispersing to landscape, that basically all runoff from all impervious areas of the site is managed by routing it to either dispersal or to a bioretention facility. And the instructions and template are included in the manual. Anyone have any questions about that have come up about applicability that we can cover here? Often these come in the terms of what to count towards the threshold. And this is often a source of some confusion. Is yes, impervious surface that is built on the footprint of existing impervious surface does count towards the threshold. So if you're redeveloping a site and you say, well, it was already impervious, I'm making it less impervious than it was before, the treatment requirements still apply. Because the criterion is what you built. There are particular exclusions. I think the best way of understanding it is that everything's in unless it's specifically listed as being out. Of course, interior remodels are excluded. Exterior work of routine maintenance or repair, including putting on a new roof, is excluded. One question that comes up is, well, what if you had a one-story building and you added another story to the building and it's got a whole new roof? And that's getting into the gray area, but I think most agencies and I think most regulators regard that as being substantial reconstruction and requires that it be included in counting towards the threshold for E12. Pavement resurfacing, I provided a picture here of the sort of activity that is not covered, that is excluded, is, asphalt overlays are not counted. If you get into tearing up the whole roadway section, it then becomes, as it is, as it has been throughout the Bay Area up until very recently, and still is under the Phase 2 permit and provision E12, something of a gray area. It really depends on the extent. It's a local call. I will note that in the recently adopted municipal regional permit that's in effect in the South Bay counties, the Water Board made a pretty good attempt at trying to clarify that and say that if you go down to the top of the base course, then that triggers the requirement for the square footage of the area in which you do that. And so they are, we're now working on, how all that's going to play out during that permit term. Something to keep an eye on up here. But as it is, the pavement resurfacing is out, but deeper work is considered more or less case by case. Raised decks are out. Anything that drains to the sanitary system doesn't go to stormwater, is that those areas can be excluded. And then when it comes to pervious pavement, the key thing to understand there is that if you want to put down, gravel on top of a couple of inches of gravel on top of clay and drive over it, that does not qualify as a pervious pavement. It's still considered to be impervious. But if it's built according to the criteria that are on page 4.3 of the manual, which have specific requirements for how it needs to be built, basically granular pavements need a rigid border around them. They have to be reasonably deep. The surface below them can't be compacted. If they're built that way, they are not impervious surfaces.
Dan, we had a question in the chat about how will ADUs be handled? Maybe related to SB9 or other issues there.
And that is a very good question. And I think on that, of course, there's nothing specific in the permit because the permit is a lot older than housing policy now. But the idea is that the same thresholds will apply. And so if you have a project on an existing lot, an additional single family home is being built, that it would not be covered if it didn't create or replace 2,500 square feet. If it creates 2,500 square feet and up, then it would come under the small project requirement.
And there's another question in the chat, and maybe you're going to get into this when you get into the small project compliance, but somebody asked, what about downspouts to rainwater collection systems? Yeah,
and that's one of the options under a small project, and we will get to that and I'll touch on it. 50% rule is often a area of confusion, partly because there are different, it's worded in different ways in the municipal regional permit, in effect, in the South Bay counties versus this language, which is the older language, which still exists in the North Bay counties permit in provision E12. But they basically, as stated here, is that the comparison, you do a comparison of the impervious area that existed before the project and the impervious area from the project as proposed. And if it goes up by 50% or more than 50%, then the existing surfaces need to be retrofit with LID to the extent feasible. And the project data form, which is included in the template in the stormwater, and actually both templates for the small project and for the regulated project templates, there's these things to fill in, and this is really intended to be a way of determining whether the 50% rule applies. And then there's the question of hydromodification management, which I almost didn't include because we haven't had to deal with it. And I'll explain why we haven't had to deal with it, because people see it and see that it's in the permit and ask the question, and it's also perhaps something to watch out for the future. So the standard for phase 2 municipalities is in provision E12F of the permit. And states the post-project runoff shall not exceed the estimated pre-project flow rate for the 2-year 24-hour storm. I'm going to get just a little bit wonky here and say what this was intended to accomplish and why it actually is a somewhat misdirected or misconceived standard. The purpose of hydromodification management control, as it's been put into permits, is to avoid the situation where those extended durations of flow coming off of impervious surfaces. So your streams are now running at moderate height, somewhere around here, over long periods of time. Can cause erosion of the stream banks, because the whole time that they're running at that level, you have the potential to begin moving sediment, and that even though those flows are not, particularly turbulent or rushing, that the amount of stress that they put on the stream banks over time will break off pieces of sediment, and they will move downstream, and over time you get downcutting and you get widening of your creek banks, and pretty soon you have something that looks more like an urban stream, which does not have the same biological value as streams that are unaffected. The standard here really refers to a flow rate, which is somewhere up here around bankful stage, which is more or less corresponds to about a 2-year storm, is here. The difficulty in using this as a control mechanism is that if you achieve this by detaining and then releasing flow, that would allow you to control flows above this amount, but discharge them after the passing of the storm down here. And if you think about that, that is simply going to increase the duration of flow at this level. And that's what you've accomplished with your detention and release. And that, as has been found through studies been done over the last 2-3 decades, can actually aggravate the hydromodification management effect and increase stream erosion. So this is not the greatest standard, but it's the standard that we deal with, and that actually gives us a little bit of an advantage. Some years ago, McStop engaged Dubin Consulting to prepare a modeling study showing the bioretention facility that we have in the manual if it's designed according to those criteria and built according to those criteria, that it will achieve this, the post-project runoff will not exceed the estimated pre-project flow rate for that size storm. And so that is why you are not seeing it in instructions or requirements, is that as long as we follow the requirements for treatment controls for implementing LID as they are in the manual, this requirement is met, and we don't have to pay more attention to it. But thank you for indulging me in a little explanation of that status and where it's coming from. Okay. Shall we get on to talking about compliance for small projects? Okay. So what is a small project? We covered this a little bit in discussing the table in chapter 1. It's a project that creates or replaces more than 2,500 square feet of impervious area. And that can be either one detached single family home or any other use up to 5,000 square feet where it becomes a regulated project. The requirement is to implement one or more site design measures and quantify the resulting runoff reduction. That's what it reads in the permit. We have our sort of own methodology for quantifying that reduction by basically saying the impervious surface that is directed to vegetated areas qualifies for that. There is in the permit no minimum amount of runoff that is required to be reduced or treated. However, we'll get to the changes in 2019 that were made to the manual to clarify this and the expectations of municipal reviewers. In Appendix C in the manual, there's a template and instructions. And for regulated projects, we have the instructions and the template separate. But the idea here is this is so simple that you can just pick up what's in Appendix C and follow it and basically treat it as a form, which is a regulated project is too complicated to do that with. It's got a project data form, just information about the project to fill out, to show areas that are draining to a runoff reduction measure and the runoff reduction measure used, some criteria and specifications for those runoff reduction measures. It's got an example sketch in it to give a sense of the level of detail that's expected. And I'll just use this to basically show what needs to be shown on one of these for it to be in compliance and to meet reviewer expectations. Is some portion of the site here, this portion of a hip roof is being captured in downspouts and directed to lawn area. Here, this area, half of this piece is being directed to a rain barrel, which is also an accepted runoff reduction measure. Here, some permeable pavers are being installed. So the key change here, and I think the key understanding, I think this is completely reasonable, is the type and extent of runoff reduction measures required for any specific project will be determined by local staff consistent with a maximum extent practicable standard. And the question that maybe we want to discuss, or that certainly will be discussed for specific projects, is, in this case, what does maximum extent practicable mean? And maybe the first way to get at that is to sort of set the parameters on both ends of what it doesn't mean. It doesn't mean zero. It doesn't mean the absolute minimum. It doesn't mean that just finding one place and doing what, some piece of direction, like one of these, for instance, on this site, would necessarily be enough. So on that side, that doesn't reflect a requirement. On the other side, it doesn't necessarily imply or require that all impervious surfaces need to be have their drainage directed to a runoff reduction measure like dispersal to landscape. Unless, of course, that is relatively easy to do. And if it's easy to do without spending a lot of money, I think, you know, any amount that can be done without having a major effect on the project, without requiring huge amounts of construction or engineering, is reasonable. And most of the development that we're dealing with on these small projects where it's creating this level of impervious area, it's in a suburban, or many or most of these are going to be in a suburban environment where it's generally pretty easy to disperse runoff. The ratio here that we're looking for is no more than 2 parts of impervious area of roof to 1 part of vegetated area. That can usually be achieved. In this case, maybe it could also be achieved on the side yards. You might be able to get pretty close to doing the whole house area, almost all the impervious surface. On the other hand, driveways are kind of catch as catch can, and sometimes it's easy to divert runoff from them off to the side, and sometimes it's not, and sometimes they're, you know, very much sloping and draining towards the street. So it's a judgment call on those things, but the idea is to do as much as you possibly can without doing a lot of, you know, really adding to the scale of the development. Does that stimulate any questions? Anybody have any experience with these that has come up? We have a poll.
Again, if people have any comments, they can feel free to write them in the chat or raise your hand and we will call on you.
Hi, Rob. This is Manije. Hi, Rob.
Go ahead, Manji.
Yeah, I don't have any question, but I think a few people don't have their microphone off. So there's so much static, I guess. If you can, please let them know.
I will try to mute folks that are adding to that. Thanks, Manji.
Hey, Rob, it's Lee. Rob, can you hear me?
Ali, did you have a question? It's hard to hear you.
Yeah, well, I just wanted to talk. I asked Rob in the chat that I think one way residents are getting away with this is that hardscape isn't necessarily needed to be permitted. So on drawing plans, it would be easy enough to not show that they're placing a tennis court or a basketball court in their backyard and get away with that. And then all of a sudden they're back there with no permit, and because they don't need one, and now it's over 2,500 square feet. So I don't know how we get away with that unless it's a policy that each city and county starts regulating.
Typically for larger projects, Ali, you know, we're asking for the, you know, everything you're going to be doing on the site. What is the impervious before and after? But you're right, in some of these small projects, and particularly as you mentioned in the chat, ADU projects, they're not necessarily going to tell you about the new patio and the new walkway. I haven't heard the tennis court one before. That's new. But yeah, we do see that a lot with people not including the patio, the other impervious on the site.
I have a quick question.
Go ahead,
Matt. Maybe I'm relatively new to this, but given my previous background, when I see these recommendations to deposit water next to the building or next to the house or whatever it is on the property, it's not as ideal, I guess, from like a foundation drainage and just drainage standpoint. So I wonder if that's ever come up, or if seems like it's in conflict with good practice that other folks are taught to get the water away from the building and off the property.
Yeah, very good question. One that comes up a lot, and not an easy or pat answer. The way that I try to frame this is geotechs have to do what they have to do. So if you have a larger project and a geotech engineer is involved, and their license is on the line, they are going to make a call about what is adequate protection of a building foundation. However, at the same time, I can say that in my own experience, I have seen more cases than not where the expertise of the geotech was, yes, it's completely acceptable to put in an impermeable vertical liner, typically plastic, on the side of the bioretention facility or dispersal area to protect the foundation. And so as long as that's there, they're comfortable with it. And so I've been involved in a fair amount of projects where, there was a little bit of back and forth on this and eventually a compromise, but the sort of modal average on that is that it's the impermeable barrier, and I'll try to touch on this when we get into the design detail discussion, is sufficient for that. And you really want to do that because you, particularly in more densely developed sites, more urbanized areas, you don't want to give up landscaped areas that are adjacent to the building from being used as bioretention facilities. It makes your overall compliance too difficult if you do that. So I'll show some examples of pictures as we move on where bioretention facilities are located adjacent to buildings, and even large buildings, and that was handled by proper foundation design and or by impermeable barriers between the dispersal area or bioretention facility and the foundation.
Thank you.
Dan, there's a question in the chat. Do runoff reduction measures in a small project have to meet the LID requirements?
As well, in the answer to that is in the permit, no. I think the desire of the reviewers and the sensible approach is that generally they should. Those requirements are already, we try to state them not too strictly. I think if you looked at this example here with the discharge of 200 square feet of roof area runoff discharging to 300 square feet. Now, this is 3 times the minimum 2-to-1 ratio here. And so how much of a stricture would you want to put on this area in terms of requiring that it be graded so that it tends to pond water that runs off onto it rather than letting it flow off? And my sensibility in this is that you want people to do what they can. Again, sort of this maximum extent practical standard. But on the other hand, you don't want somebody to give up the shape of their landscaping or their lawn in order to have like a pool with rigid size here, is just to say that you require them to do that. So, making sure that the soils are amended, making sure that it's not too steep. Obviously, you wouldn't want this on a very super steep hillside. But some reasonable compromise in there in terms of meeting the requirement. A little bit of vegetation, mulch, soil amendment, maybe some mild grading. It should be sufficient in most cases, and the dispersal will work fine. I know that's not a hard and fast answer, but I hope it's adequate. Okay, we're finally getting a little back and forth here. I really appreciate it. Thank you. Looking at the time, we are 15 minutes ahead. We have a choice of going for the break, which is in the deck where we're planning to do it, taking it a little early, or I could jump on to the discussion of LID site design and coordinating the design team. Let's see. How about a show of hands? Let's try that. How many folks want to take a break now?
Folks can either, yeah, exactly. Use the reaction to raise your hand. Oh, that's a lot of votes for.
What are you seeing there?
I am seeing about, gosh, 12, 15 want to go now.
Give it just another minute and then we'll ask the reverse question. Let's see who's awake. So we're raising hands now for folks who want to take a break now.
And or thumbs up. It looks like at least one.
Hand or thumbs up, some indication.
Like we're
okay,
about 20 folks.
About 20? Okay.
Yeah.
Okay, now everybody put those down. Undo, so we got a clean slate here. How many folks want to jump into the next presentation and delay a break another 20 minutes?
Key question, Dan.
Well, it makes what people pay attention to. How are we doing?
We're at about 11 for that.
All right. I think we take a break now.
Sounds like it. All right.
Okay.
When we do, there is one question in the chat that we can start with.
That's great. We'll start with that when we come back at 9:50.
Perfect. See you all then.
All right. Thank you. Okay. We're back. I see a couple of hands up. If if you want to ask a question, leave your hand up. If it's left from our poll on when to take the break, please take your hand down.
I think they've been up the whole time, Dan, so I think those are leftovers. We do have a couple of, there's an additional question. So there's two questions now in the chat, so maybe we can start with the discussion from there.
Yeah, sure. And I will say what these are, and then we'll get a little deeper into them as we move through the topics. The first question is about one of these questions that comes up from time to time is trying to integrate our LID objectives with other objectives for the sites, in this case, so-called fire hardening of lots and restrictions on putting flammable materials next to buildings. And it's stated here, bioswales next to the building are not acceptable. Please comment on how both LID and fire safety can be achieved, especially on small lots. And I think we can get a little bit into that actually in this next section on good LID design, site design and site planning. I think really the way to dig into this is to get into some of the details on it, and I hope maybe we can have a little more discussion about it. Is what does adjacent mean? What does non-flammable mean? And then look at the types of situations where the fire hardening objective applies and what the landscape, land use context is there. Because clearly in a highly urbanized situation, maybe the same fire safe requirements don't apply as in something that's closer to wildlands. And of course, the LID needs are very different too, and the availability of space for implementing fire retention, perhaps a little further away from the building is also there. So all that to sort of explore how much of a problem it is and the dimensions of it and what types of solutions might apply in different situations. So we can get a little bit into that, and I hope we can get some discussion going out in this next section on coordinating the design team, which, as I said before, is sort of a key part of our whole effort today. And then we have a question which is more clear, cut and dried. I was asked, do we plan to discuss the design guidelines for V1 and V2 and whether they are required if hydromod is not necessary? And the answer to that is pretty straightforward. V1 and V2 are the volumes that are required in the reservoir of a bioretention facility and the volumes that are required in the subsurface area below the soil layer. And that's part of the design criteria that was developed in Contra Costa and adopted in at least one other county. They are site specific. They need to be determined for types of soils and for rainfall in that particular area. And the answer to that, simply enough, is in the North Bay counties under the hydromod requirements in E12. We found that that study that was done, that modeling study, found that the basic standard design, which is in the manual, 4% sizing factor, 18 inches of soil, 12-inch gravel layer, that meets the E12F hydromod standard everywhere. We use the wettest place to measure that, and found that if the treatment requirement as we've laid it out is met, then the hydromod requirement is met. And that simplifies things a lot. Avoids a lot of issues. And so hydromod is something we just haven't had to dig into. And here about reducing plants for water conservation. And I love questions that I've already anticipated because I've got a good visual for that. So we can jump into that. And I appreciate the question. All right. Is anybody going to stop us from going forward and say, no, don't go ahead. I got something I got to ask. All right, let's go. All right, so the title on this really comes from a lot years of experience working with a lot of different people in different counties in trying to solve this problem of how do we get good LID, which is really integrated into the project, LID that achieves those objectives of being part of the design, integrated in a way that people encounter it all the time, they value it, that it's part of what their daily experience. How do we get there given that the reality is, is that typically in the design process, if you've ever been involved in it, you're told it's too early to worry about the drainage now. We're not doing engineering, we're just laying out the site. And then after the site's laid out, well, now it's too late to change things and do a proper LID design. That's sort of like the standard way that it works. And so we're looking at different ways and different angles to try to figure out how do we break through this conundrum and get to that integrated design that we would like to have. So starting on this, in the manual, I'm referring to page numbers here. If folks have it up on their screen or maybe even have a paper copy on their desk, you can look and see that these are all issues, these objectives are addressed in the manual. But what we're looking for here is that first of all, the site plan, landscaping plan, and stormwater plan are congruent. And certainly seen cases where even the set that shows up at the design review board, and you open it up and you leaf through it and you say, well, here's a bioretention facility shown here, and here's the landscaping plan, and the bioretention facility is not shown on the landscaping plan. What gives? And so that's sort of like a basic thing, is to make sure that all the plan sets and the plan set showing the LID facilities is reflected in the site plan, the landscape, and the landscaping plan. More than that, we put this down as a goal, and again, the purpose here is that if we want that long-term resilience, we want LID to be something that when it's installed, it's preserved for generations. The answer to that, as best we understand it, is high visibility, well-trafficked areas, make them a focal point in the landscape, make them something that people encounter. If a facility is underground, if it's in the back of the development behind a fence, if it's something that people go around rather than stand next to, it just is not going to have the same likelihood of being cared for and retained and being there over the life of the project. Another piece of this is designing site drainage. I think most drainage engineering, both because of its simplicity and because of the objective of dealing with peak flows. Most site drainage is, well, you take all the different areas of the site and you drain them to one downhill point and you put a basin there or whatever you have to do in order to control flows. And with LID, we're looking for this much more complex way of looking at site drainage so that landscaped areas are made self-treating and are not drained directly to bioretention facilities, and that where possible, impervious roofs and pavement areas are drained into landscaping informally in a way so that it just infiltrates, using that 2 parts impervious to 1 part pervious maximum ratio. And only bioretention facilities only receive drainage from roofs and pavement. This is another key aspect, which is a engineering technique, really, but it achieves all these other things, is to keep your drainage run short and use surface drainage. So we're really looking for the situation where the downspout connects into the bioretention facility, the pavement flows to one corner and into a bioretention facility, but it's flowing across the surface. If you're looking for a LID design that's going to have problems, find one where the runoff is directed into a storm drain inlet and then into a pipe, and pipe somewhere, unless that's on a situation where you have a steep slope and you're taking drainage from up gradient areas and you have a nice flat down gradient area. which does occur sometimes. But in general, you want to have that drainage just going across the surface and into a nearby bioretention facility. Bioretention facilities need to be level or nearly level, and we address that in our design criteria. This is how you build them. But if that isn't addressed in the layout, you're often too far down the road already that, if the site layout has put a bioretention facility someplace where it's on a 4 or 6% slope or whatever, then the engineer is asked, okay, now design this facility. The engineer finds out it has to be flat, and you have the problem that it's now you need a wall on the upstream side, on the upgradient side, maybe on the downgradient side too, in order to build it level, and that adds to the cost. It has aesthetic consequences, and is a problem. So we want that included in this process of integrating the design team. And then we have this objective that in subdivisions, bioretention facilities should be in a common accessible area. And this is not always honored. It's certainly, there are perfectly nice designs where, for one reason or another, usually having to do with issues related to the subdivision map, that facilities are located on individual lots. The concern with that really relates to this overall concern of having a sustainable, resilient, robust system on a watershed scale. Is if folks have a bioretention facility and it's on their own lot, that means you're going to be dealing with one property owner and their feelings about their own lot, and you'd much rather be dealing with a facility which nobody has that kind, no one individual has that kind of ownership of, because then you're going to run into fewer problems with them wanting to do something different from it that violates the integrity of the facility and not being able to do anything about it because of political reasons.
Hey, Dan, quick question in the chat. Somebody asked, can bioretention be sloped as long as the entire gravel layer is submerged before overflow occurs?
That's a very good question, and I'll answer it briefly now. Maybe we'll get to it a little bit more under design and construction. But basically, the answer is it's not a good idea at all. And the reason is that as soon as you put a flow that has any energy into it, and the surface of that mulch and that bioretention soil are exposed to movement, you end up with your mulch and some of your soil down at the downstream end of your bioretention facility. I've certainly, folks, I'm sure there's folks here who have gone by after a 5-year or 10-year event, gone out and done the tour of the bioretention facilities and seen the amount of movement that occurs. The way to avoid that movement is to have the bioretention facility surface be flat. And so you have ponding, quiescent ponding that usually doesn't make it even up to the overflow. It just creates a nice pond a few inches deep, and then everything settles back down more or less where it was, and everything can just be raked and moved around, and you're back in business. So in general, it's just better not to. And I totally understand the difficulty that creates if you're trying to do drainage design, grading and drainage design, and you're trying to make up some elevation between 2 points, and you got a bioretention facility that is going to be flat, and it often pushes you towards needing to do walls that you'd rather not have. Yeah, so here's a photo, actually an example of this is in a subdivision. This is one of the early ones that were built in Contra Costa. Good example, the end of a private street. And here, this bioretention facility has a nice natural look to it. And it's located in the common area, which is common in the same way that the street is common. All right. So this process of thinking about how to integrate LID bioretention facilities into the site The key aspects of this are first looking at how the site drains, either in its currently developed state or if it's undeveloped, what the natural topography is like, and where it connects to offsite drainage, whether that's the municipal storm drain or a more informal drainage, and where are the low points, and or the existing, often keyed by the existing inlets. And then starting from there as a guide to how the whole site needs to be developed. So, we're trying to look at this at the earliest stage of development in terms of understanding the drainage before the buildings and the driveways and other circulation elements have been laid out. And so this process of integrating the landscaping plan and having that the bioretention facilities placed within the site plan in a way that takes into account the drainage at the same time that the landscape architect is looking at how the aesthetics of the site work, that the site planner is looking at how the circulation works, and that the whole issue of how are we going to route the drainage, how are we going to locate the facilities, where are our focal points, all comes together. And as difficult as that may be, I think the reward is apparent when you see it done well. This bioretention facility actually has some design details that could be different. I think it probably is sloped. I'm not crazy about the way that the side slopes come into it. But in terms of how it sits on the site, this is kind of what you're looking for. Is, here it is in this higher density, not really high density, but higher density townhouse development. And you can see the level of interaction with the landscape, with the buildings, that this is really has been conceived and implemented as part of this development. We had that question about bioretention facilities next to buildings. So this is a development here in El Cerrito. Currently, this picture is only like a week old. And there's a couple of things I wanted to point out about this. Perhaps most importantly, the front and center aspect. Here is a bioretention facility that is totally integrated into the entrance of this building. It's going to be seen by whoever enters or leaves this building every day. It's part of their experience. It's part of what the developer is selling in terms of, yes, you get to live in this great building in this kind of semi-urban environment, the bus stop right out front, and when you walk in the front door of your building, here is this lovely garden. And it's also treating stormwater. And I want to note in particular this sign right here, which so the language is a little bit elliptical, but what it indicates is, and you can't read it, but what it indicates is that this is designated public space. This meets the public space requirement that is in the conditions of approval for the project. Is that the developer is, required to either pay for, into a fund to develop parks nearby, or to provide some kind of recreational space as part of their project. And this developer chose to provide some, benches and seating area next to some vegetation, rather than, pay into the parks fund. So they get the benefit of having the recreational space right there next to their building as part of the selling point. And they use the bioretention facility as part of that area. So you've got multiple benefits going on here, including the benefit of meeting this requirement to provide open space. And I'll contrast this just as a little bit of a lesson here with a very similar bioretention facility, which is around the back side of this building, which is not front and center, not all bad. I mean, it's there. It's got a bench next to it. Here's the open to the public sign indicating that they also got credit for this area as being part of their publicly accessible open space. But because of the problem of not carrying through the design objective of having surface drainage, this bioretention facility ended up down in a pit. And while it still fulfills the developer's objective of getting credit for the space is not nearly as aesthetically valuable as the one that they built in the front of the same building. So just a point on integration of the design team and having the drainage designer in there from the beginning and understanding the objective and what needed to be accomplished here. And perhaps it would have been possible to avoid having this pit with a railing around it. And it could have been more like the more pleasant version, which is in the front of the building. This is a bioretention facility, and this is sort of the ultimate, if it can be achieved. I think the most valuable and valued type of facility. This one drains 7 acres. It's a retrofit. But here we have a facility which treats stormwater. It's a park, and you know, a new pocket park, and it has you know, both active and passive recreation as its uses in addition to treating stormwater. And so really that effort of trying to integrate the design team, understand all the objectives, understand the way that LID can benefit the site and not have it siloed both literally and figuratively as being a utility, as being something that the engineers and the drainage people, you know, worry about, but having it be something that is a benefit, a community benefit part of the project is really what we're aiming for. Here's another example. This is a church, and this was originally designed as a very large version of the plants at the bottom of a pit. And in this case, city staff really put a lot of effort into working with the engineer and landscape architect on this site and developed this design where the congregants, you know, can hang out outside under this awning, and here they are, you know, next to this attractive vegetated garden area that also serves as the LID treatment, the bioretention facility, for a very large parking lot just behind where the camera is. So I think the steps for the design team, obviously you need this collaboration. The question to ask at whatever project meeting held as early as possibly can in the design process is, how is LID integrated into aesthetics, the landscaping, and the circulation? And then carrying that forward, instead of it just being an idea, I'm thinking, okay, well, when this goes to the design review board, we want the LID to be fully developed, or pretty much fully developed, you know, except for maybe drawing the cross sections. And we want to show the design review board or the design review commission, which most projects are that meet certainly the regulated project criteria are going to go through, and show them how the LID works with the landscaping, with the site design, with the circulation, all the things that they're reviewing. So do we have a poll here? We have a poll. We have a poll, and then I hope folks will jump in with some questions or some comments on this process. All right.
All right, maybe I'll end it there.
Yeah. Well, this is an interesting result. Is because and an encouraging one because I don't know how we address the first two. How we get developers willing to pay for the professions to work together, or how we get people out of their tendency to focus on their own work and be siloed. But if the good solid majority here feel the design teams aren't yet aware of the need, well, that's something we can do something about with outreach and efforts like we're doing right now. And I think we've the people who need to be spreading the word about this, who are in the best position to do so, are here today. So trying to get this idea out, making reference to what we're trying to achieve here, using some of the reasons and justifications that have been discussed today, and trying to get across that idea that this is for quality of the project and for success of the overall effort of implementing LID on a watershed scale over decades. This is coordination of the design team is something that really needs to happen.
So Dan, there was a couple of comments in the chat. Somebody suggested perhaps a fourth option, which is developers aren't aware that the opportunities that integration of LID offers. Someone else opined that maybe that was utopian and that the developer and investors may not be willing to sacrifice that much for LID. But there is someone had a question that I think is an interesting one in this context of the design team integration, but it's does a bioswale have to be planted? Someone mentioned that they have a small site where removable deck panels over a bioswale would give more usable space for the site and achieve the LID goals. So what do you think about that? Yeah,
and the answer to that question is yeah. To be functional, they have to have plants. And so the idea of, we're going to have everything that it has, but we're going to deck it over. Unless it's a very high deck and get some sunlight, it can grow plants. It needs to be planted. Just want to point out that I'll take the being called a utopian as a compliment, as I usually do. But the advantage that we have here is I regard the mandate that we are implementing here as being, yes, it's both a hoop to jump through and it actually is could be a drag on necessary development of housing and economic development. And we try to reduce that drag by doing things like producing a manual and giving training sessions so it's goes more smoothly to implement. But the issue of how much area is willing to be sacrificed. There's two things. One is it's 4%. It's mandated, which means that okay, we're not pushing this ourselves. We're simply implementing what the state has required, and we're trying to figure out the best way of doing it. And then also noting that, as I was showing in the urban development with the apartment building, that had an open space requirement that the developer was fulfilling on his site. So he would have had to have that vegetated area anyway if he was going to implement that. And that he made it bioretention is a way of meeting the mandate without taking up more space. The 4%, one of the ways that we sort of checked on that and figured out, well, we're going to be able to do this mandate without too much effect or drag or need for more space on development sites, was really to look at minimum parking requirements that exist in suburban areas, although we hope those are being reduced as we go forward. And looking at the minimum landscape requirements that go. How much landscaping do you have to have in a parking lot? How much landscaping do you have around a building? How much setback do you have to have from the street? What's the minimum amount of landscaping on a site? All these things are independent, existed before LID for the most part, came along as a mandate. And if we can fit LID into those parameters by the genius of our design and our design teams working together, then we have the opportunity to achieve these objectives and do this work without needing to really change what the site design parameters in terms of the total amount of space that it takes up, but rather in terms of the way that it's arranged and the way the site is designed.
Dan, we have another question on the chat. In some cases, project phasing might present an issue. My example is a rough grading plan for a large site. The developer is hoping to get started with a rough grading plan for mass grading. The LID measures are present on the plan, but more conceptual than detailed. Any advice on the level of detail, calculations, etc., that we should require at this stage? It seems like an all or nothing situation. My hope is that the designers really evaluated the LID needs and layout before moving forward with a rough grading plan.
What a great question. Yeah. Because I would say in my own experience, I started out laying out guidance, on this, working on guidance 20 years ago. And with the assumption that, well, if you're able to lay out the footprints of the bioretention facilities and they related roughly to the amount of impervious area that you were that you plan to create on the site, and that you met that 4% sizing requirement, that basically that would be enough. And the harshness of practical experience has led to really seeing more and more that I don't think it's quite all or nothing, but you really do want more and more detailed consideration of the engineering before you move on from, or even start that rough grading process. So I would say, just kind of as a somewhat off the cuff, is you need to look at the impervious areas that are being drained. You need to look at which direction the drainage from each is going. You need to identify where in the overall layout of the site the bioretention facilities are, need to go from a drainage point of view. And you need to consider how that fits in and integrates with the landscaping objectives, the aesthetic objectives, and the circulation objectives. And so that should be part of the conversation. I don't think you get too far down before, you need a pretty good idea of what the landscaping is going to look like and what the site circulation and layout is going to look like before you get into rough grading. So far, not too bad. And then I think the key is that you need to realize that those LID facilities need to be flat. And that's really a key problem. They need to be flat, and they need a way for the drainage to get to them and to be carried away from them to towards the site discharge. And so I think that's about the level that you need with a rough grading plan. Fortunately, you've got the criteria, the design criteria. They're in chapter 4 of the manual. It's going to tell you, basically how these things are going to be engineered. But knowing how they're going to sit there and what elevation the rim of it is going to be and how that's going to sit, trying to conceive it in 3 dimensions is where you need to get to, I think, before you can go ahead and complete a rough grading plan. Because if you haven't done that, obviously, then you're going to run into problems where you're going to have to come back around and say, oh, geez, we need to cut a slope here. We need to put a wall here. We need to worry about how to get drainage from here to there, or we didn't before. So I think that's the point, around the point that you need to get to. Great question. Others? Follow up on that? Okay. 10:30. Okay. Preparing a complete submittal. All right. Move on here. And this is this piece is a little bit more instructive. For maybe for folks who don't have a lot of experience with this yet, but I'm going to just go over sort of the key pieces of when I open up a stormwater control plan and I look and I see whether this has been dealt with or not. That's sort of the key piece of knowing whether it's going to be something that can be, corrected and made complete with a few comments, or whether it's something that has to be sent back and say, give it another try, is whether these key elements of the submittal have been completed, mostly related to the exhibit. So when we put together the post-construction manual, say, 4 different ways of saying the same thing, because different people learn in different ways. They're going to focus on different aspects of this, but the manual includes step-by-step instructions. It has a checklist of what needs to be into it. There's a template to follow, and then there's the example submittals, and all these are meant to be coordinated. So whatever questions or whatever isn't understood or isn't yet conceived, isn't quite shared yet, one of those 4 will help move that mental process of achieving understanding along. This is from the example from the residential subdivision example. The permit states actually the requirement for this specifically is the site needs to be divided into drainage management areas. This means the entire site is that there really should be no area of the project anyway within the project boundary that is not delineated as a drainage management area. and drainage management areas should be assigned to every area within the site. It's best and really pretty much required that each different type of surface, whether it's impervious roof, pavement, or landscape, is a separate drainage management area. There's good reasons for that in terms of making it easy to iterate a design and easy to follow. The permit also requires that it be shown that each of these drainage management areas drains to a treatment facility that is then overall sized to handle the runoff from all the tributary drainage management areas. So the first thing to look for in an exhibit, the first thing to prepare, is to ensure that the drainage management areas are clearly delineated. Each is labeled with a unique identifier so they can be identified in the calculations, the square footage for each, and the surface type is clear. Same, and then for bioretention facilities, the footprints are shown, and they're identified, and it's useful to have the square footage on there as well. Here are some common problems that come up in stormwater control plan exhibits. One key sort of tell that there might be a problem is if there's a storm drain inlet that is not a bioretention facility overflow, because or an area drain in a self-retaining area. If you have a storm drain inlet that's just there in the conventional way, like serving the pavement, you got to ask the question, well, where is that runoff going after it enters that storm drain? And it could be that it is piped down, a slope or a hill to a flat area where it was more convenient to locate a bioretention facility. But that situation is relatively rare. Typically, storm drain inlet, definitely something to look at as what's going on with it. Another common fatal error that you see in exhibits that come in is that the applicant or the applicant's engineer has been told or believes that their site is eligible to use non-LID treatment. That's extremely rare, and even where it's allowed, it's usually not necessary and should be discouraged. So it's another kind of tell that the stormwater control plan is going to have problems and needs to be reworked. Another somewhat less common issue that comes up and less obvious is the use of pervious pavement, which may be a great idea, or it might be an idea which is not going to work out. And I'm just noting here the experience with having bioretention, having pervious pavement on a site that is meant to reduce the amount of bioretention that's required, and then realizing that while it's being proposed and why it is a route or a means to achieve compliance, the applicant is actually not going to be able to follow through with what they're proposing, because either it's extensive installation on clay soils, and the intention is to drive on that pervious pavement, and the pervious pavement that would be required in order to hold up structurally with no compaction at the bottom of the excavation is going to have a very, very deep section. And so the proper pervious pavement on a clay soil for a road or driveway or even a parking lot is generally going to require a very deep section, which is going to require a lot of excavation, potentially a lot of off-haul, a lot of backfill with base course material, and then the pavement on top of that. And if it hasn't been thought through, that's going to be a problem that you want to warn the applicant that that's not, once they look at the cost of it, they're not going to want to follow through on it. Similar problem exists on slopes, is pervious pavement on steep slope, on slopes above maybe 2% or so. It can be done if there's sort of a complex excavation and keying into the slope to make sure that the base course is installed flat, even if the pavement is slightly on top of it is slightly sloped. The amount of effort, amount of work, amount of excavation required on that is quite extensive. And so usually is not going to be followed through on either. And then another problem that I've encountered in reviewing stormwater control plans a few times is that there's, in this case, it's showing a drainage channel that's right here that this bioretention facility was intended to discharge into. But it would have required a new outfall into it. And a new outfall into a drainage channel or a creek is something that is pretty complex to permit, not likely to happen, and means that the drainage plan or the LID plan may not be viable.
Dan, we have a sizing question on treatment systems for bioretention. The question is, the current MRP allows for sizing criteria for treatments to follow the 3 sizing design criteria: volume, hydraulic design basis, flow hydraulic design basis, and the combination flow and volume design basis. If BASMA is a guidance tool which strictly requires using a 0.04 0.04 sizing factor flow design basis to size bioretention, can the other 2 methods be used?
And we actually have a slide with that, where that sizing factor comes from, which would be useful to get to explain where we're going with that. And then we can sort of get into some of the details of answering the specific question about the other methods.
And a second question, is there a life expectancy for the growing media in a bioswale? In other words, does it self-compact over time with inundation and have to be replaced?
Good question. We will get into that under soils, which is coming up. And the answer is really no. The idea is that the tilth of that soil should improve over time because of biological activity. And there are plenty of bioretention facilities that are 30 years old or more that are performing just fine. And that's really the key. It goes back to the thing of why these design requirements are so specific and so prescriptive is to make sure that you have a medium which is where that is going to happen, and not a medium where it clogs up over time. Okay. Certainly, Howard, if you could help me out and make sure that I don't go by those points on the soils or on the 0.04 sizing factor and forget to address those. Calculations. The point here of having this, having this laid out with the drainage management areas and the numbers of the square footage and the surfaces of each identified. Purpose for doing that is, or one purpose for doing that is so you can put it in a spreadsheet or a calculator, or basically so you can do your calculations. And so one of the things that happens in stormwater control plans is, because of the process of iterative design and the way it's easy to edit something and not do a complete edit. Sometimes what shows up on the exhibit and what shows up in the calculations don't match. So one thing to watch out for, but the idea is that you get this very close correlation between what's in the exhibit what's shown in the calculations. And so that basically demonstrates the compliance with provision, with the E12 provision, that all runoff or runoff up to this certain amount be treated. So here we go. Here's the 4% sizing factor slide. So this here is the criterion, which was one of the criterion which was being referenced is in the MRP. It's in C3D, and it's in the same language as in E12. It was developed in the 1990s in LA before it became sort of statewide standard. I'll back up a little bit to say those criteria that are being referenced. One, the most commonly used one at the time that it was written was to design settling basins. And it's still in all the permits. That's where that whole idea of water quality volume came from. You had to capture this water quality volume and hold it quiescently for 24 or 48 hours and let the pollutants settle out. The criterion still appears in all the permits, even though the method that it was designed for is now not allowed. You can't use a settling basin as a treatment mechanism. So that particular criterion is kind of out. There are series of criteria that were designed for sand filters, which was another technology that existed in the 1990s. A bioretention facility is basically the same as the sand filter in the sense that we were trying to handle a continuous flow of runoff produced by a storm without a whole lot of detention. And so the sizing criteria that was appropriate to use for that was the criterion for sand filters. Now, there are a couple of different ways of getting to this number, what rate intensity to use. 0.2 inches per hour is pretty much where they end up pretty close to that, not a whole lot of difference. And the process of demonstrating the other two methods is pretty involved, and there's questions about the methodology that was used. So 0.2 inches per hour is pretty straightforward. And then from there, the criterion calls for a maximum surface loading rate across this area of the sand compost mix of 5 inches per hour. And the division of this amount of flow by this amount of area going through here gives this ratio, which is where the 0.04 sizing factor comes from. So the 4% sizing factor is rooted in those other in a fairly deep analysis of the sizing criterion that are in the permits, which have their own long history and really should have been updated a couple of permit cycles ago. Essentially, it's accomplishing the same thing. You could tweak it a little bit, and there are efforts to tweak it to make these a little smaller in some areas. The applicability of those is something I could say could be looked at going back to the experience of actually implementing the 4% sizing factor. There are now thousands of bioretention facilities in the Bay Area. The vast majority of them have been designed using the 4% sizing factor. Is there a need to make that smaller? I won't say that there isn't. Contra Costa recently in 2020 adopted some very narrow circumstances, basically starting with no surface parking on the development, with an allowance to use a factor which takes advantage of a criterion which I think is specific to the MRP, that allows for anything that captures and treats 80% of this total amount of runoff can be used. And so continuous simulation was used to show that this reservoir has the effect of retaining some runoff and allowing it to be filtered, and therefore this can be smaller essentially. And so that is being used in some very narrow circumstances in some relatively high density development. But whether it's necessary, I would say the first thing to look at is can this 0.04 be achieved? And even in the examples used in Contra Costa and some of the other counties, it's first required that it be shown that this is infeasible. Is that using the 0.04 is infeasible? And I think that's a pretty tough, for the vast majority of developments, that is a pretty tough hurdle to overcome, because generally with good design, with paying attention to the integration that we were talking about before, looking at the minimum amount of green space that's already required, looking where bioretention can go on the site, this is achievable. And it's also not a huge economic burden, because first of all, building bioretention facilities at 4% on development sites is not a huge portion of any overall cost of construction on the projects to which this applies. And if with proper design, it can almost always be achieved without reducing the uses of the site.
Dan, we have a couple of questions or comments in the chat, so I'm going to take them in reverse order. One of them was, well, why doesn't the infiltration rate of the native soil matter?
Good question. And we'll get into that when we show the diagram, but well, actually, we can use this one right here. So the way a bioretention facility works is the runoff comes in and is percolated through the sand compost mix, and let's say the vast majority of the time, for typical rain events like the one that we just blessedly had, that runoff will collect in this layer here below the underdrain and be infiltrated into the native soil. And this is why the specifications, are prescriptive in terms of requiring that this be uncompacted and ripped to promote infiltration here. That's sort of like the best outcome, and we want as much of that as we possibly can. When this backs up, though, and the infiltration of the native soil is restricted, and you get a storm with a higher rainfall intensity, then this gravel layer starts to fill up. And when it fills up, it goes to it eventually goes into this underdrain, perforated pipe underdrain, which actually should be located right here at this interface, and then routes that runoff to the storm drain. So the reason that the infiltration of the native soil rate doesn't matter is we're trying to get everything we can out of it, but if we can't get it, say for instance, usually the most typical reason this fails on this end is that the bioretention facility was located in a place where the soils are completely saturated during a rainfall event or during a heavy rainfall event or at the end of a particular wet season anyway, because of the way that the clay lenses are oriented in this slope. You end up with saturation or even upwelling in this spot right here. And when that happens, you get practically no infiltration, but you still get the full treatment requirement. It's just that instead of going into its native soil as infiltration, it goes out through the underdrain. into the storm drain. And you're still achieving the same regulatory requirement, still performing as it needs to. It's just that you're not having as much beneficial effect on reducing hydromodification, and you are whatever ineffectiveness of the filtration process in terms of letting pollutants through then is happening here, rather than basically having your pollutant discharge be zero, as it would if you had infiltration into the native soil.
Thanks, Ted. So one other post in the chat was a reference and a link to the Sacramento State OWP LID sizing tool. So I don't know if you wanted to comment on that tool at all.
Trying to figure out how to say something nice. I am not all that familiar with that sizing tool. If it's been updated, then my comments are not current. But what I saw in that is that it had a number of options in the sizing tool that were not allowed in the permit language. And that's because they were actually developed at around the same time, about 8 or 9 years ago. And so when the permit came out, it actually foreclosed on most of the options which were in that OWP sizing tool. So that's where I've been at with that. And so I think that it's, it was an interesting effort, but I'm not sure how useful it is. And if we're using bioretention, this 4% is pretty straightforward.
It sounds like the commenter said that the tool was updated in 2019, so maybe that warrants another look.
Another look, yeah.
And then a question from the chat also: if the water table saturation zone rises into the gravel, does it increase water getting into the storm drain that would have otherwise risen to just below grade or stayed in the ground?
Yeah, maybe. This distance is 18 inches, so that's pretty high groundwater. Below ground level, we're supposed to have a 6-inch reservoir, so really the depth that you need is 2 feet. I imagine that happens in some cases. The implementation of bioretention in tidal zones is something that really needs to be looked at carefully if you if you're doing a project that is right at the shorefront in a tidal zone. But otherwise, in most developments, that 18 inches is going to make sure that you don't have much upwelling, or if you do, it's going to be very transitory. Okay. We taking care of these here? That's great to have a little back and forth. I really appreciate it. Move on. Okay, let's move on to construction drawings. So first, to start out here is, why do we need this consistency? Why are we going for this thing where we, probably the 4% sizing factor is an important piece of it, but maybe not as important as always having flat, always having the sand compost mix, always having class 2 perm with very few exceptions as the base layer, always having all the layers flat and the interface with the native soil ripped, having a concrete catch basin style overflow rather than an upturned plastic pipe. Each of these things, and as they've been developed over time, is really oriented to achieve that overall goal of ensuring that these things last, that they are maintainable, that it's easy to tell whether they're working or not, that someone who's familiar with bioretention facilities can look at a particular bioretention facility and go, yeah, I can see what the problem is here, or that one's working well. And all that is facilitated by having this consistency in design. It's fairly prescriptive design criteria, and following through to make sure they're followed in the construction process. At the same time, the idea of doing this is that this doesn't restrict the way that bioretention facilities look. And I think one of the unfortunate effects that we've seen is we want bioretention facilities to operate like a bathtub, where they're flat and they fill up and they drain. But a lot of the time they end up looking like a bathtub, which isn't the most attractive thing to have in the in the front of your facility. And there's really no reason they have to look that way. Once they're planted and put into the visual context of the landscape, they can look like anything. They can be any shape. They can look like a swale or a drainage pathway. They can look, kidney shaped, oblong, long and skinny, fit into a street frontage. Any of these, they can be planted in, a natural landscape. They can be planted in as a more formal landscape. And all those options exist as ways of fitting them into the site, while still observing the design criteria that are in the manual. So the key here is that the construction documents should show that the key engineering criteria are met. And really, is that the facilities have to be designed specific to the site, but there are probably only a few things that need to be focused on, that need to be individually developed for each facility, beyond the kind of reciting the design requirements that are in the manual. So, just pointing out here, this is on page 410 of the manual. This is sort of the key. This is an illustration. It is meant not to be either, on the one side, something to be cut and pasted and handed to the contractor and say, build me one of these, because there's not enough detail in here. But on the other hand, these criteria which are listed here are not ideas, they're requirements. And each of these things, as they're applicable in the particular situation, should be observed. Some of the key ones, I think actually here, we had that question about close to putting bioretention facilities close to buildings or foundations. Here we're showing a vertical moisture barrier if needed to protect pavement or structures. That's the standard. Of course, it is something that geotech needs to review and sign off on. Key point, no compaction, rip to loosen. Having the concrete drop inlet or a manhole with frame here, and we'll see an example of what happens when that isn't necessarily observed. The 6-inch ponding, the specificity of the soil mix. All of these things that are listed should be observed and should be reflected in construction documents. So the best way of communicating and getting across the key aspect that all layers are built flat and that the top soil elevation is flat. From what I've seen, the best way of making that clear is in the plan view on the drawing, on the grading and drainage plan, where elevations are called out, is that these 3 quantities are called out, and it's made clear in one way or another that these apply across the entire facility, so it's flat. But here's the top of soil. bottom of the soil layer and the bottom of the gravel layer called out at each point. This makes it easy to, or relatively easy to set up when a construction level is set up on the site. And the plans are spread out across the hood of the pickup truck, that the key elevation can be referenced, and that each of these can be identified about where it shows up. And then when these are installed, you've got somebody walking around with the rod, getting the beep and showing that each of these are installed at the elevation that they should be. And so this is a way of taking it from the concept that we were talking about with the different design professionals working together and developing the concept, the engineer identifying, okay, it's going to be this flat thing and it's going to be here and it's going to be this footprint. And we're going to put on the plans these elevations because we've worked out how the grading works and this fits in with our grading plan. And then we're going to call them out. So then when the thing gets constructed, it gets constructed as it was conceived and as it was designed. Same here with the grade elevation, obviously a key elevation where the overflow is. And you can look right here and say, okay, in this particular case there, this was where a 1 foot reservoir was required. In Northbay counties, this would always be 6 inches or half a foot. But the difference between these two numbers is key. And here, you can see you got your 18 inches of soil in your foot of gravel underneath. So this is actually some things that come out of experience and are recommended. I think this goes probably a little bit beyond what is in the manual right now, but they're definitely, just from having reviewed stormwater control plans, it's really great if you can have these notes on the details for the bioretention facilities. Calling out the Caltrans specification for the Class 2 perm. So, we can confirm what's ordered, what's delivered. Soil mix in the Phase 2 permit is a lot looser as it stands now. It just says a mix of sand and compost. But generally, practically in the Bay Area, given that the BASMA mix is referenced in the municipal regional permit in effect in the South Bay counties, and soil suppliers know how to make it, and it meets all the requirement in the Phase 2 permit. It's useful. I don't know whether it's always observed to just reference that, but certainly that can be referenced, and then you've got a whole series of controls to know that that's what you're getting. The location of the under drain is, a photo of this. Yes, there it is. Is this technique that here's the gravel layer installed, and then a groove is sort of dug in it with a shovel, and this is laid down so that those perforations are at a level where the amount of interstitial space in this gravel, basically this subsurface reservoir, is maximized, and you're getting the benefit of storing and promoting infiltration to the native soil of the absolute maximum amount of volume here, while at the same time preventing the fines from your soil layer, which is going to go here, of getting into the underdrain and being washed out. Again, said a few times, underlying soil is to be uncompacted and ripped to loosen. Making sure that there is a planting plan and irrigation plan that applies to the bioretention facility is in the construction documents before construction goes ahead. These are sort of the key things that the landscape architect or the landscaper, landscape contractor need to know. Is these 2 points is no soil amendments, fertilizers, or pesticides. none of the things that are, might be used with conventional landscaping, or even the surrounding landscaping. Don't use these in bioretention facilities, only the approved mix and aged compost mulch, and maintain that specified top of soil elevation following planting, which is a fairly common issue. Is, I think many of us have seen the situation where the civil contractor did their job correctly, everything's built flat and correctly, and the soil's installed right, and that 6-inch reservoir is there at the top of the facility. And then as the project is wrapping up, the landscape contractor is brought in and hasn't sort of been clued in, and ends up saying, oh, well, that looks a little low, let's fill that up with mulch. And so the reservoir ends up, filled up with mulch or even with soil, and so you don't get that 6-inch reservoir. So that needs to be communicated through the landscaping plan, and make sure the landscaper knows it.
So Dan, one quick question, and actually there's one legacy question, which I think you're going to get into now, which was the ratio of sand to compost and gravel. And so we'll get into that, I think, in this piece. But Jeff Skinner from FNAP asked, how do you handle public works projects in areas that don't have water availability for planting?
We have a section on plants, mulch, and irrigation, and we'll deal with that one then. And then we'll get into the sand to gravel ratio here. Great questions, thank you. Any other questions on construction documents? Raise a hand or take a moment to type. All right. All right, so this is what's in provision E12E to F3 for the planting medium. Is it has to sustain a minimum infiltration rate of 5 inches per hour. It has to maximize runoff retention and pollutant removal. And then it says a mixture of 60 to 70% sand and 30 to 40% compost may be used. We had a question come in as we were preparing this about, doesn't compost leach nitrogen, which I'll address now. But just noting that these requirements are pretty much similar to what was in the permits in the South Bay, and then they added this much more detailed requirements beginning with the municipal regional permit, I think in 2011. And so now there is sort of a whole mini industry of producing the material that meets this specification. But let's get into the question of compost leaching nitrogen, and the answer to that is yes, unknown as to for how long and under circumstances and what needs to be done about it. The first point is that nitrogen is not a pollutant of concern yet, or doesn't seem to be the limiting factor in promoting growth of algae in Bay Area waters, and particularly not in the Bay. They're not nitrogen limited. So there hasn't been that much focus on it up to now. In terms of what happens when bioretention facilities are installed, the real questions that are here are what happens over time. So there have been some samples taken from bioretention facilities that were recently installed. We haven't seen samples, and I don't know of a study that would be more linear in terms of what does it look like after 1 year, 2 years, 5 years, and whether that stops being a problem. And then there's the question about whether it might be possible to control the amount of nitrogen leached by controlling the C to N ratio in the compost itself, which is one of the factors that is actually in the basket specification. So that's what we know about that. Anything else on this? Yeah, so that's the planting medium. This is again a specification which is mandated in the MRP in the South Bay counties. I don't know the extent to which this is implemented under the somewhat more loose E12 requirements as implemented in the North Bay counties. But this is just to address an issue which I've seen come up, is the BASMA spec, most recently updated in April 2016, does a good job, maybe an overly good job, of ensuring that the test results taken at the yard, from samples taken at the yard, are then submitted to a laboratory and come back, and that's, you know, that they meet these requirements, so they're very detailed. The problem doesn't address making sure that that's the same material that gets delivered to the job site and installed. This is the specification as it exists in BASMA. I think, again, an industry has sort of come up around the regulations, so the soil testing labs know what they're looking for, and they use this, and there's forms. BASMA created a form for checking off that each of the detailed requirements in the specification are made. We managed to negotiate into that spec and into the MRP requirements by extension that, particularly for smaller projects, that you don't have to have a laboratory test for that particular project. The yard or the soil supplier can say, yeah, that's our regular such and such mix. We send it in every 120 days. And, you know, we call it, you know, the BASMA mix or the bioretention mix or whatever. And we can just send that out with an order and have it installed without the requirement to have a specific test of that batch. And just noting that if this mix is used, that no infiltration rate testing attaches to that. The need, however, really is that you know, even if you have this verification that the soil mix meets the requirement, you don't know that that's what you're getting at the delivery site. And so this is something that a lot of permittees have attempted to address in one way or another. Some of the permittees in the East Bay use a on-site infiltration test. Some of them report that they get fairly consistent results on this to ensure that it meets the minimum 5 inches per hour. I'm of two minds about the utility of it. I think the most important aspect of looking at what you get on the site is actually the physical properties is probably a better predictor of the performance over a long period of time. What you're looking for out in the field is something with a grainy, gritty texture that does not clump even if it's wet. Can maybe squeeze it a little bit because it's got the fine compost in it, which will make it a little spongy, but it won't hold with any stickiness, which would indicate the presence of clays. And then what really shows the presence of clays is if you rub it around in your hand and then drop it and your hand is stained. It's just that shows that you've got clays in there. The problem with that is that even a very small percentage of clay, certainly anything above 5%, but I think even less can be a problem, is that there is actually a interaction of the clay particles with the sand particles. Anyone who is a gardener and has made the mistake of trying to mix sand into a clay soil in order to loosen it up, it doesn't work. What happens is you get kind of an effect of turning it into concrete. And something similar is probably what's happening with bioretention soils, which have been mixed and then now are being repeatedly wetted after installation. And if they have too much clay in them, you can get that problem of them suddenly showing a very, very reduced rate of infiltration sometime after installation. So that's why the mix exists. It's why no native type of sandy loam or anything is used. Rather, we use this engineered soil, and that it needs to be checked to make sure that it does not have a substantial clay component. If all those things are true, then it's fairly reliable that this will continue to infiltrate at the required 5 inches per hour over a long period of time. And again, what we're looking for with this is that once you get plants, you have rotting organic material. Because you have plants, you have earthworms and bugs in here, and the idea is you want this very dead soil as it's installed to turn into a living soil, both because that gives you better pollutant removal, more ways of processing pollutants and of fixing them to soil particles, but also over time, the idea is that all that biological activity gives this tilth and keeps the soils open. We had that question before about, do they need to be replaced? And the idea is that by creating a biologically active thing here with the plants and all the things that go with having plants, that it essentially becomes self-sustaining. And again, we have examples of bioretention facilities that have been operational for many decades and still perform great. This one has been in place a decade. The one that we're looking at right here, it has actually a nearby stream overflowed a couple of times and filled it with silty material, silty water. So it's had a little bit of a rough life. In all cases, because it was biologically active, those plants came back up very quickly. It did not require digging out after those incidents. And subsequently, you can see that it continues to infiltrate quite well. So that's what we're looking for, is something that's resilient when something negative happens to it and is sustainable over a long period of time. Questions? Right. Okay, we can go on to plants, irrigation, and mulch. I know we have.
Sorry, there was one question. Somebody wanted to know where. Can you give locations of examples of bioretention that have been around for decades?
Of course, we started with the requirement for bioretention out here almost 20 years ago. So yeah, that qualifies for decades. I would give one example of one that I worked on very early that I really kind of like is if you're ever in the town of Danville, the Rose Garden shopping center, which is right off of 680 if you're going through there. It is has quite large trees in it. Is still performing fine. Front and center, the first thing that you see when you drive into the place. So that's one. I think, yeah, particularly in Contra Costa, there's a few that I could point to, and I can follow up that question, and I'll try to send you a short list. It's kind of fun to go around and see them. I mean, if you're into this sort of thing, actually, and even Google, having Google Earth and Google Maps allows this thing where you can say, oh yeah, I worked on that project 20 years ago. I wonder how it looks now. And if it's visible from the street, sometimes you can go pay it a visit instantaneously and see how it's doing. Other questions? Here's our subprovision E12 E2F 8, a requirement for an appropriate plant palette for the specified soil mix and maximum available water use, which is, that last phrase is an odd way of putting it, but if you read it closely, it means, okay, so don't plant anything that you don't have the water available for, is what that I think means. It comes off a little odd. And so that's a requirement. So it needs a plant palette. Plants are required. I think the sort of ready answer to that was the question of what plants should we use is there is no one easy answer for this, because the process of selecting plants to grow on any site requires considering the site. How much sun do you have? Is it exposed to wind? What temperature zone is it in? And of course, the soils, recognizing that we're using this sand compost mix. And so you need a landscape professional that is paying attention to that. And I've certainly seen plenty of landscape designs associated with bioretention facilities where they had missed one or another aspect. Either somebody went to the table and picked plants that, oh, these are good for bioretention facilities, but they didn't pay attention to the specific situation. And or they did the opposite mistake, which was to choose plants that were aesthetic or that were wanted or seemed to be right for it, but without considering the particular characteristics of the fast-draining bioretention soil. When both go together and the process is understood, I think there are a very broad variety of plant palettes that can be used for different effect. We had that great question of what about bioretention facilities that are located in places where irrigation is not available? And fortunately, I have two pictures here of one. This is a gas station in Orinda, where the water wasn't available, and these are succulents that seem to be doing pretty well. I assume they get some. Somebody goes out and perhaps puts some water on them from time to time, but basically, I think this is a solution to that kind of problem. The plant list that's in Appendix E, I believe that it includes, yes, non-irrigated sites. Options may be somewhat limited. So obviously, sometimes you can't get everything you want in terms of, it's the aesthetic result and also having plants in a non-irrigated situation. But the plant matrix covers all of these things. Is perennials, ground covers, small trees, even large trees, heat, wind, sun, shade. All of these situations have been thought through in terms of, can you find a plant that will work in this situation, that will work with these soils? I think a lot of the failures that we see of planting is this lack of understanding, lack of forethought, a lack of research into what will work in these particular situations. So I think we deal with a lot of issues about the difficulty in retaining plants, about water use, where the guidance is there, but the guidance hasn't been sufficiently followed. In terms of reducing water use and the requirement to try to minimize the amount of water use, obviously using something like succulents is one option, but the other is to take the lessons of I think in some ways we're spoiled in the Bay Area we've got these clay soils that tend to retain water pretty easily. And so the common practice among landscapers, landscape professionals is, yeah, we'll just put some spray irrigation out there, and you know, it'll hit this whole area, and the soil will stay wet enough that stuff will grow fine. And that overall philosophy and way of doing irrigation is not going to work in a rapidly draining soil. And the way to address that is you have to invest more in irrigation. You have to have more controllers. You have to use drip emitters. They have to be spaced reasonably. It is you know, somewhat more expensive to install, somewhat more expensive to maintain. But if you want the flexibility in plant palette, you want a more lush look. You're in a, you know, obviously we've got the extended summer drought because of our climate, let alone we've got the drought situation we have now. But using the drip irrigation and smart controllers is totally the way to go, and you just often don't see the investment in it.
Dan, we have a quick, slightly unrelated question, but going back to kind of the basics of it all, do all regulated projects require a maintenance agreement?
Yeah, and actually, I'll jump into it now. We've got, I think, one more section after this on operation and maintenance, which actually, let me hold that because 2 slides from now will be into the O&M question.
Excellent.
So mulch, as with plants, you know, what's required here is, and you know, I don't think there's a regulatory requirement related to mulch. No inert materials can be used. This comes up fairly frequently, to use rock, gravel, or even recycled rubber or glass. That doesn't mean that, particularly in an adequately sized or even oversized bioretention facility, particularly if it's one that's being designed for active or passive recreational use, you can't have some variety of coverage in there. But overall, a bioretention facility with rock mulch on it. There's a few problems that are going to result from that. One is it raises the question about, you know, whether you're getting that, effectively getting that, you know, biological activity that you want. Other issues that come up with rock that I've seen is you put in the rock mulch and then plants start to grow up between it, and you got no way to, or weeds start to come up, and you got no way to get in there and deal with that without removing it. Also, rock or gravel mulch can heat up like crazy on a sunny day and kill plants. And certainly anything that you know, is a waste or you know, might have contaminants is inappropriate. I'm convinced that the best mulch to use is to use the same product that's used in the soil mix, largely because it has less tendency to float. Bark mulch is often used because aesthetic reasons, but it does tend to float and move around when the reservoir fills. And then this key point we touched on before about not filling the reservoir with mulch. Let that depression happen. Questions on mulch or soils? Okay. So here's my spiel on operation and maintenance based on experience. So a little while after we got into this, back a couple of decades ago, it was the mantra that, well, you know, in order to ensure that stormwater treatment facilities used generically, continue to perform. They must be maintained. The maintenance must be ensured, by the property owner going out there and doing something with it all the time, regularly after storms. We need O&M manuals, we need O&M requirements, we need matrices, we need a inspection program to make sure that municipalities go out there and check that these on a regular basis that these are being maintained. I won't say none of that is all that is not true. In any way, it's mandated. We're required to do it. You have to have an O&M program. The answer to that question of is a maintenance agreement always required? And I see Rob has cut and pasted the requirement there is you have to have a mechanism. And the mechanism that municipalities pretty much selected to work is the agreement, because of both because you can actually implement it and because it's enforceable. You hope you never, like any other contract, you hope you never have to, you never have to have one. You never have to invoke it. But also just going back to what we're trying to achieve in terms of having thousands and thousands of bioretention facilities all across our landscape, maintained and kept in place, given the limited resources and limited authority of municipalities. The key is to have these integrated into the urban landscape in a way that they are valued and that you have, a sense of community responsibility for keeping them in good shape, rather than saying, well, this is a thing that we have to do and we're going to use enforcement mechanisms to make somebody do it. And so the big lesson here is that if the facility is designed and constructed correctly, including its placement on the site, that there is rarely anything that needs to be done with maintenance being a problem. And if it is a problem, it is easy and straightforward to correct and usually involves the maintaining the vegetation. On the flip side of that, if the facility is not installed correctly and there's a problem with it, there's often practically nothing you can do to fix it. And so you end up going back and inspecting year after year or however often your maintenance cycle is. And yeah, it's still not working properly because it's not going to work properly. And these photos provide some examples here. The one on the left, they did a really nice job installing this, and the developer of this housing project really cared, wanted to do this right. But this was early on, in the early days of implementing the requirements. And what you can see there, this was taken, I think, about 2-3 days after an approximately 5 to 10 year storm. And this facility is nicely maintained. There's nothing you can complain about it. But what I'm noticing on here is that you can see that the material that's shed by these grasses is accumulating on that grate right here. And so that indicated that during this relatively modest storm that a properly designed bioretention facility would have handled without overflow, this overflowed and some portion of the flow didn't get treated. Although I'm sure a lot of it did. But the reason that happened is that this is at the down gradient end of a large bioretention facility, and the runoff came flowing across it, and it accumulated down here, and it filled up, ponded on this end, where relatively total pond volume is limited because the whole thing is sloped, and the accumulated vegetated material, which had washed down, then washed into the grate. Not the worst thing to happen. Most rainfall falls in storms that are smaller than this one, but it just shows that, well, if it had been built flat, not a maintenance problem. It wasn't built flat, not a lot you can do about it. Here's an example of a facility that was more or less abandoned because the project went belly up. This building was not occupied for a number of years, and because it wasn't occupied, no maintenance was done on the bioretention, but this was done properly. And what I'm missing here is the photo that I got off of Google Earth. This is in Concord. Is that this is now completely replanted, looks great, and this is now a place that sells fireplaces. But obviously when they needed to redo this, all they needed to do was to scrape that soil and remove the weeds and replant it, and boom, back in business. Relatively small maintenance problem, one that they wanted to solve anyway because of their own attachment, own reasons for wanting to have something attractive in front of their store. So it didn't really require any prompting from the city. And the facility was restored to completely proper operation despite the lack of attention to it in the past. And this one is outside a major grocery chain, again installed early in the game. This pretty good, the reservoir is maybe a little shallow, but overall I checked the soil and it still had the right tilth to it, still nice and gritty. Obviously neglected in terms of allowing weeds to grow in it, but doing its job. But that this overflow is now too low because somebody drove something over it. Now it's up to the permittee here to go back and try to get this big chain to do something about this now broken piece of plastic pipe that was used as an overflow. That's among the reasons as well. If that had been a concrete catch basin set at the right elevation there, first of all, it probably wouldn't have been hit. And if it had been hit, it wouldn't have been moved. So again, the sort of design and construction needing to be right, and then maintenance is rarely a problem. And then the O&M verification process, really the key is yeah, you got to pay attention to them. The main thing is to make sure nobody did anything to them. Nobody filled up the reservoir with mulch. Nobody decided, oh, well, we need that space, we're going to cover it over, or we're going to park on top of it, or anything like that. So that's the main focus. And so just going.
Quick question. There's a question in the chat about just to take a half a step back towards the maintenance agreement around public projects. So how do you set up maintenance agreements around publicly owned or maintained projects?
And again, that goes back to that requirement that there be a mechanism. And the mechanism is the Public Works Department, maintains a database and goes out there and, maintains them. And that's, I think, considered to be sufficient mechanism. I've never heard that challenged.
I'll offer this up locally here at the county. We do essentially sign a maintenance acknowledgement, essentially, that just says, yes, this is our facility and we'll be maintaining it. So.
Okay. So this just lists sort of in those detailed specifications, which are in Chapter 4, how this relates to long-term robust operation, which then relates to that goal of being able to have thousands of facilities across the watershed that continue to basically maintain themselves and are going to be around for a long time. But at each of these, the location of the underdrain pipe, the soil mix specification, the consistency and the configuration, having the top of soil be flat, requiring plants, having a precast concrete overflow, having a delineation of a curb around the edge that shows where the facility is. Each of these things is there, not just because somebody dreamed up that it was a good idea, but based on the experience of watching these things perform in the field and developing criteria to maximize a robust operation while minimizing required maintenance. Here's that same facility I showed earlier. This is community members out there volunteering to take care of the vegetation because it's a nice park and it's a community project. But here's your O&M, here's your O&M going on of your bioretention facility, and this is publicly owned. Going on with community involvement and no cost to the owner, to the agency in this case. Key points for O&M in the stormwater control plan is it should just state that this is known, so this is the way that things start out. Is the no synthetic fertilizers or pesticides or soil amendments. And the basic thing is go in there and remove the trash that accumulates typically right at the inlets regularly, inspect before the rainy season and after significant storms. And with the grasses that and shrubs that are typically used in bioretention facilities, this can be, depending on how aesthetically nice they need to look. I've seen bioretention facilities that perform great, and the vegetation maintenance on them is to go in there in February and cut everything back. The neighbors might complain that it looks like hell for a few weeks until things warms up and things start growing again. But in terms of keeping minimum costs, particularly for publicly owned facilities, that is often completely adequate.
So Dan, there's, if you can go back to that picture, actually, I had a feeling there was going to be a question on this one. So is the rock on the bottom counted as treatment area?
So this is actually a way oversized area. Over here is this entire piece is the treatment area. It drains 7 acres that are upstream, upgrading it this way. So the easy answer to that is that you don't really have to answer the question because the area that is vegetated covers the minimum easily. In terms of whether it could be, my sense is that the value of the long-term maintenance, the aesthetics, the community value, the usability is pretty significant. And what you're trying to achieve here is to make sure that when this thing floods, that you get the infiltration through here. And that's going to happen certainly through the vegetated area. You have roots that are going to come, underneath here to some and keep this, at least some portion of the area underneath the rock, relatively alive. If I'd given you a more recent picture, you'd see that this is narrowed as the vegetation is encroached on either side, although there's still a pathway through there. So I think it really relates to this question of, are you designing a park-like facility where this is part of your volume, retention volume, which is very useful to have during big storms? Or, do you have something that's more like what we were looking like in front of a building where you would want to make sure that the whole thing is mulched and vegetated because it's much closer to the minimum size and you need that level of performance. We definitely want to encourage the use of active and passive recreation in bioretention facilities. Okay. There's no more questions. Let's go to this. And I think our timing is working out well after all. After all we've talked about, anybody want to plug in anything in the chat or raise your hand? Say anything about this facility that you noticed is good or bad. This is in downtown Ukiah, by the way. Looks like a tripping hazard. Well, okay. Exactly. A problem to be solved is, I think it's interesting what they did with providing a curb around this. But yeah, this is a concern of public works directors everywhere. The issue here is that this needs to be flat. The elevation of it is determined that you want it to be 6 inches below the inlet, which is obviously here where the runoff comes down into it. So there's your point. Everything needs to be that elevation. But as you move up toward the sidewalk side, that means that you end up with significant reveal here. And they've done that by either a high curb or whether that's a low wall. And then obviously that turned out to be something of a problem. I think it's more aesthetic rather than a curb to put around here that they put this this little railing. It's kind of neat, actually. I hope it worked out. Some concern, the concern about tripping hazard is always there. Curb inlet is blocked with vegetation. Hard to see from the photo, but yeah, that could be a problem, and it might be something that they should move that out of there. Are there any inflows? Yeah, the inflow. Actually, this is one of the things that you can see on here is that there's no catch basin along here. So the drainage area to this spot is likely from somewhere back behind the camera along here, along the street, at the crown of the street, over to the side, and this whole area is draining down to this point. So effective placement of the bioretention facility. Other points?
Other than several people mentioned that the mulch itself may float, it does look like well, it's hard to tell from this angle just how elevated that overflow inlet is. It may be set too low to where you're not going to get much ponding before water starts flowing into it.
Yeah, it might be high enough, but it is plastic. And if anybody I can't imagine that anyone would ever drive so recklessly that they would come over that curb into the bioretention facility, but I'm kidding, it's going to happen. And it would be better to have that be concrete. What about this pole here? So might well be unavoidable, might be a compromise that had to be made, but you can bet down here there is a bunch of concrete below there. Would have been better if it wasn't in the bioretention facility. Often the reason this happens is, it's something that could have been avoided with planning, particularly when you have this on a site where you've got more options, on a parcel rather than on the street. It could have been avoided to have part of your bioretention facility taken up with the basic foundation or concrete base for a street sign. Does the tree need soil rather than BSM, bioretention soil media? And the answer is, in my experience, typically not. There's a group in the MRP counties that's just gone around for years and years about the problems of trees and bioretention soil. And I participated in some of the discussions, and I kind of was like, well, but we've got 20 years experience now, and we've got great big trees that are sitting in bioretention facilities. Let's go figure out what was done right, why those work. There are a couple of things that I think sort of intuited out of that experience. One is that trees can totally get going in bioretention soil media. The direction on them is to make sure you stake them properly, as this one is, because obviously that soil media has no structural glue to it. It just will pull up, so trees can tip over. So they need to be staked. But I think more than that, as the tree grows, and this is a concern to any arborist, where are the roots going to go? And if you have trees in any situation, even in a regular urban tree well, and the roots are bound, the tree will have a limited life. And that can be a problem. The key with success in bioretention facilities seems to be, if you can avoid it, not to have, basically this be a well with sides all the way around, but have a way that the roots can extend at least in some places, out into other soils. Seems pretty tough to achieve here because you're completely surrounded by pavement, but it's also a somewhat large facility. So you hope that that tree can find a way of extending roots perhaps through the gravel layer or out the sides in ways that it accesses the more water retentive soils that are around there. Someone noted that in this situation, it would be likely that the soils below are compacted. Yes, almost always in this situation, right? I mean, this used to be street, so it must have been compacted. And you hope that they follow the guidance that's there and over excavated or at least ripped those soils to promote infiltration when it was constructed. Yeah, and they are using the wood chip mulch, which will float more. What else? Oh, the fact that this is obviously given some aesthetic value. Let's put a bench here for people to hang out. So it's it's got that community benefit. It's got that sense of connection. Question about drainage management areas and the 4% rule. So two responses to that question. The question is, in one of the slides earlier, one of the drainage management areas was landscaping. Does the 4% rule apply to that area too, even though it is a permeable area? So answer being that, first of all, if you recall, one of the objectives in trying to do good LID design is to avoid draining landscaped areas to bioretention facilities. So if possible, the landscaped area should be self-retaining or self-treating, meaning that if it's sloped, it runs off without being directed runs off the site without being directed to a bioretention facility. So that's the first answer to that question. And then if there's no way, because of the way the site's configured, that the landscape area can be prevented from flowing, from draining towards the bioretention facility. In the criteria which are in Chapter 4, it's instructed to apply a runoff factor of 0.1, so 1/10 to that landscaped area. So you can have a lot of landscaping area going to your bioretention facility without having to greatly increase the size. Let's see, anything else on this? I want to point out here. Might have covered all the key aspects of it. And here we are at 11:55. So I think it's a good time to take any last thoughts or questions. Wrap up. Rob, do you want to, is there any way that questions could be answered in the future, or that the slides could be posted, or thoughts?
Yeah, so yeah, good. We will post this recording up on the Mixed Up website, and anybody else can access it from there. Any questions that come in, I guess I would direct people to their countywide stormwater programs, the representatives from those, and I think we're all on the call today from Napa, Sonoma, Marin, and I think there's some folks from Solano as well. So I would say direct your questions to your coordinators. If there's specific questions for Dan that didn't get answered and that your stormwater coordinator can answer, we may solicit Dan's help and get those answers back to you as needed. Otherwise, we do have a couple more minutes. If anything is burning in people's minds, please put it in the chat or unmute and raise your hand. I'm gonna post one final poll out there just to get folks' reaction to the training. But yeah, it looks like there was one comment in there that folks, Chris anyway, appreciated the class, and to have the kind of instruction and experience with the manuals is helpful. So good. I'm glad folks found this helpful.
All right.
All right. Well, if there's nothing else from folks, I will I'll leave the poll up here for a second and then close it down and post it for everybody. But I thank everybody for your time, especially Dan. Great to have you go through the manual in this kind of detail with folks. I know in the future, under future iterations of the permit, we may make changes to this manual, but it probably will be relatively subtle. We have our marching orders, and we'll hold these trainings periodically to help. It's like we did get at least one other question in the chat. Do the plants provide an engineering element without which the bioswale wouldn't function, or do the plants have mostly an aesthetic value?
I think the best answer to that question is the plants are necessary to make sure that the soil continues to perform over the long term. That is the key thing, because if these were just sand filters, you'd have to be out there maintaining them all the time. So the biological activity keeps the soil pores open and basically makes the filtration function work. So that definitely is an engineering element. But then, you don't want to discount the aesthetic value and the community benefit either. All right.
Okay, not seeing any other questions. I want to thank everybody for your time. Again, thanks, Dan.
All right.
Look forward to a future meeting.
All right.
Thanks, Dan.
Thanks to everyone. Thanks to the staff, and thanks to all the participants for your attention.
Good.